Okay, we are recording. This is virtual office hours 6.1 through 6.2. These are homework questions that I may or may not have went over in the class, and some of them are repetitive because I've went over them in several classes. So what I'm going to do is I'm going to cut out all the duplications. In other words, if one student sent number 5, I cut 2 of them off and I'm just showing number 5. So that way I'm not doing problem after problem after problem over and over and over. So our first question is 6.1.18.6. 6.1.18.6. Now I think I've went over this one, but I'm not sure. It sure does sound familiar. Yes, we have went over this one, and I'll go over it again. Let me get rid of this. Hold on just a second, and I'll get rid of this, move that out of the way. Okay, we've got a binomial distribution. It's right here. Now, you can pick whichever way you want to deal with this binomial distribution. I'm going to write it on the whiteboard or on the document cam so everybody can see a few things. And if you do one of these problems, you should be able to do everything that I'm fixing to write down. And if you can do everything that I'm fixing to write down, you are good with 6.1 and 6.2. So I've got a probability distribution, and I've got 5 events: 0, 1, 2, 3, 4, 5. And I've got 0.274 and 0.578 and 0.111 and 0.032 and 0.004 and 0.001. Now the first thing I need to be able to do is test, and all these are between 0 and 1. And if you add them all up, I have no idea. So I'm going to add them all up, and let's see what they equal. Hopefully I can do this without having to do the mouse, because the mouse slows me down. Let's see what happens. 0.274 plus 0.578 plus 0.111 plus 0.032 plus 0.004 plus 0.001. And that's equal to 1. So both tests have been met. And those 2 tests are the following. Excuse me. The first test, all the probabilities are between 0 and 1. The second test is if you add up all the probabilities, that's equal to 1. So both of those have been met. So I'll take my handy dandy green highlighter, and that means this is a binomial or probability distribution. Now, what else will they ask for? Well, they're also going to ask you, this is 6.1, so 6.1 will ask you for the mean and the standard deviation. Mean is equal to the summation of x times p of x. And the standard deviation is equal to the summation of x squared times p of x. And add all those up and subtract the mean squared. Now, 6.1, that's pretty much it. That's pretty much it. Now, also, you need to make sure that you understand that the average is also called the extended value or the expected value. Now, it's expected value whenever it's in an application with business, finance, insurance, gambling, The mean is called the expected value. So just show you that so you don't freak out when you see the word expected value. Now, I'm going to go to the handy dandy calculator and I'm going to type in my numbers and I'm going to do it on the handy dandy calculator. So, stat, edit, 0, 1, 2, 3, 4, 5, delete. And then I'm going to go up here and I'm going to hit 0.274, 0.578, 0.111, 0.032, 0.004, and 0.001, and delete. And now I'm going to go to stat, calculate, first variable statistic. I'll make sure you have L1 and L2, that's the first column and the second column, and hit calculate. And our mean, excuse me, our mean is equal to 0.917. And our standard deviation is equal to 0.7471. Now, as I've been telling you from chapter 3, whenever you have the mean and the standard deviation, you may be asked to draw the curve. Whenever you hear mean and standard deviation in a directions, you may be asked to draw the curve with 3 standard deviations on the left and 3 standard deviations on the right. And if that's the case, you may be asked to put that in the middle and add 3 standard deviations on the right and 3 standard deviations on the left. I don't think this question is going to ask that, but let's see what it does ask. This is a discrete probability distribution because all the probabilities are between 0 and 1, and the sum of all the probability is equal to 1. And looks like it's a little, all the data is right here with 0.274, 0.576, and 0.111. So it's on the left-hand side. So that means it's skewed right. So I would say probably it's D. And that means skewed right. It is multimodal and skewed right. It's not multimodal, it is bimodal. Sorry. Nope. It is one mode. There we go. All right. And one mode meaning right here, see that one that has the most in it? There's only one line that's on top. I wasn't looking at the graph when I did it. Okay, there's only one line that's higher than the other ones. Mode means what shows up the most. One shows up the most, has the most probability. The mean is 0.917, and the standard deviation. And remember, to beat the man, you got to beat the man. And that's Minnie, Charlie. To beat the man, M-A-N, you got to be the man, be the mean. To beat the man, M-A-N, you got to beat the man, be the mean. That's a little thing I use. Okay? And the standard deviation is equal to 0.74. It says round to 1 decimal place. 0.7. What is the possibility that a randomly selected involves 2 marriages? 2 marriages is 0.111. So you go down here and you type in 0.111. What is the probability? At least 2. At least 2 means you're going to add 2, 3, 4, and 5 probabilities up. So that's 0.111. So that'd be 0.143, 147, 148. 0.148. And that is 6.118. I like this question, and I'll tell you why I like it. I like it because it has everything in it for 6.1. It has everything in it. If you can do 6.118, you can do pretty much any question in 6.1. Excuse me. Okay? So that's it. That's how you do that problem, 6.118. So rewind, freeze, pause, fast forward, however you need to work on 6.118. That takes care of that one. 6.123/7. 6.123. 6.123/7. And let's see what this one looks like. Excuse me. Okay, the graph, blah, 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 blah. Okay, what is the probability that a randomly selected mother who's had 2005 has had 4 live births? 4 live births is 0.111. So you put 0.111 right here. Okay, next one. 4 or 5th live births. So you add them together. 0.111, 0.102, that would be 11 cent plus 10 cent is 21 cent. So 0.213. Next, 6 or more. 6 or more. 6 or more. 6 or more means 6, 7, and 8. So 2 cent and 2 cent is 4 cent, and 4 cent and 4 cent is 8 cent. And then 3 and 6 is 9, so that's 7, so that's 0.097. 0.097. How many live births would you expect? Expect. The expected value. So all those first 3 questions were pretty simple because all you got to do is read the chart. Okay. D, you're going to have to find the mean. D, you're going to have to find the mean, which is also called the expect value. So when you see that word expect, you know you got to find the mean. So you're going to have to put all these numbers in the calculator. So here we go. I'm going to move over a little bit so you can see. I'm going to have to scrunch it up a little bit. Hold on just a second. Let's scrunch it up a little bit. So, stat, edit, 0, 1, 2, 3, 4, 5, 6, 7, 8. Oops, in the wrong column. Hold on a second. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to go over here and 0, 0, 1 is 0.234, 284, 0.172, 0.111, 0.102, 0.023, 0.026, 0.048. Okay. And now we are going to find the mean. Stat, calculate, L1 and L2 on the first variable and calculate. Our mean is equal to 2.976. We're talking about marriages, so that's 3. Our standard deviation is, just in case we need it, 1.887. So that's equal to 2. So if you was to do a curve, if you were asked to do a curve, 3 standard deviations, 3 standard deviations, 3 is in the middle, that'd be 5, 7, and 9. That'd be 2, or let's see, 3, 2, 1, and -1 and -3. That would be, and your normal would be within 2 standard deviations, which would be this area right here. That would be normal. 2 standard deviations on the left, 2 standard deviations on the right. So I don't know if they're going to ask for that or not, but that's how you find the mean and the standard deviation and draw the curve right there if you need it. I'll put that there so you can hit pause. There we go. Mean in the middle, add 2, add 2, add 2. Mean in the middle, subtract 2, subtract 2, subtract 2. So 3 should be our answer. It says round to 1 decimal place. So that would be 2.3. Let's see what it says now. It seems like to me, oh, we're done. I'm sorry, I thought there was another question. Okay, so the first 3 questions, 0.11, there it is right there. Second one, you add 4 and 5. So 11 cent plus 10 cent is 21 cent, and that's 0.213 right there. And then it says 6 or more, so that's add 6, 7, and 8 probabilities, and that should give you 0.097. Good test question. I like that question. It's kind of short and sweet. You don't have to do a lot of math, and you can do a lot of it in your head. Okay, next question. 25. This is 6.125/25/8. 6.125/8. 6.125/8. Suppose a life insurance company sells a 170 one-term life insurance policy to a 22-year-old female for $170. That's the payment, premium, yearly premium. The probability that a female survives is that. Compute and interpret the mean or expected value of this policy to the insurance company. So this question is from the view of the insurance company. Now that's one thing you got to put yourself, okay? In other words, if they pay somebody something, in their eyes, that's a negative. If they take in money, that's considered a positive. Kind of like your own house. Think of your checkbook. If you pay somebody money, if you pay the air conditioner guy to service your heat and air unit, and you pay him $300, that's what I just had to pay. Pay him $300. Boom. That's a negative. So in my eyes, I had to pay him, I had to drop a negative in front of $300 in my bank account. Now, from the guy that does the air conditioner, from his perspective, I paid him $300, but he brought it in. Okay, so that's from the, if you take in money, or let's use me as an example, I paid the AC man $300, so I put negative in my checkbook, negative $300. And my buddy that works on my house, he owes me $500. He just wrote me a check for $500. That would be a positive because I'm taking in that money and I'm paying out to the air conditioner man. So for the insurance company, anytime you're talking about insurance, a payment to the insurance company or a premium, I don't know why they call it a premium, all it is a payment, okay, is a plus. A claim or a payout or a settlement, some of y'all know the word settlement, those words mean negative, just like a business. Okay, if you have to pay the refrigerator man to fix your coolers in your convenience store, that's a negative. But if somebody comes in and pays you $500 for all your Pepsi containers, that's income. That's a plus. So you've got to think in terms of expense, bringing in money, income. Okay? Payout, income. Payout, income. Now we also got something else to talk about. Live or die. Live is positive. Die is negative. I don't know anybody that thinks living is negative and dying is positive. So the 0.999539 is living. And what is the opposite of living? Dying. So the complement is going to be 1 minus 0.999539. 0.999539. And the probability of dying is 0.30 because that's a -4, so it'd be 3 zeros. And 461. So let's take a minute and color code these. Positive, negative is negative. So this probability is going to be multiplied by whatever this settlement is. This, paint that green, this is living. So living is going to go with whatever the positive is. Now, what is the positive? Let's go back to the question. As far as the insurance company goes, they're looking at a payment of $170. So that's good. That's coming in. That's a payment. $170. And that's green because they like that. But they don't like when somebody dies, because when somebody dies, they're going to have to pay out $170,000. Now the check is going to say $170,000. But since, now you got to look at this from the eyes of the insurance company. They've got 170 of your money. Okay? So on paper, they're not paying you, what is it, 170,000? They're not paying you that. They're paying you 170,000 minus 170 bucks. Because in their eyes, you gave them 170 bucks. So on paper, and I'm trying to find it, 170,000 minus 170. So in the insurance company's eyes, they're paying you $169,830. $169,830. Now let me explain this again. You've got to put yourself in the eyes of the insurance company. They may write you a check for $170,000. Okay? They may write you a check for $170,000, and the check will say $170,000. But that's not what they paid you. In accounting terms, you paid them $170 premium, and they gave you, if you die, $169,830, because they've got $170 of your money. All right, that's the way they think. I'm not telling you it's right or wrong, but that's the way accounting works. So now all you have to do is take the event, you die, multiply it by the probability of dying, plus you live times probability of living. So I'm going to put the colors together. You die times, that's the event, you die, times the probability of what? Dying. Plus, that's black because it doesn't have a color, 170 is you living, times 0.999539. Now, if this answer comes out positive, that means the insurance company is in the good. If it comes out negative, that means the insurance company is not making a profit or not doing good. So I put good, and then I'll put a big red X to it. All right, so let's take our handy dandy calculator. And let's do, since I've already got 169, let's change that to negative. So negative, second answer is negative 169,830 times 0.000461. And that is negative $78.29. Plus, and let's do 170 times 0.999539, and that is 169, that's green, 169.92. And of course, it's going to be positive because the positive is greater than the negative. So I'm just going to subtract 78.29. And we've got an answer of $91.63. And it's positive. 91.63, and it's positive. Therefore, it's a profit for the insurance company. And that's how you do a insurance expected value. Now, the first thing a student will ask me is, well, why didn't you make that negative 0.00? Excuse me, these are probabilities. I can't make a probability negative. I was just telling you that in the scope of positive and negative, death is considered negative, and that's why I put a red line under it. I'm not making that a negative number. I'm associating 0.000461 to death. That's what I'm doing. And I'm trying to get 0.9999. I'm trying to put a green line under it. I'm associating that with living. That's why I did it that way. Okay. And that is 6.1. I'm going to leave it up for a few more seconds. 6.1, 25 slash 8. Next question. Oh, let's see if that's the answer. The expected value is 91.63. Yay! Next question. 6.1, 28 slash 9. 6.1, 28 slash 9. 6.1, 28 slash 9. An investment counselor calls with a hot stock tip. He believes if the economy remains strong, the investment will result in a profit of $40,000. Profit is considered positive. So I'm going to go back to my colors again, and I'm going to set this problem up in terms of positive things and negative things. So positive, I'm going to write things that are positive. That $40,000, that's positive because that's profit, and those things are considered positive. Okay? If the economy grows at a moderate pace, the investment will result in a profit of $20,000. However, so there's another profit, $20,000 profit. Okay, however, if the economy goes into a recession, the investment will result in a loss. So we got negatives, a negative $40,000, which is considered a loss. And you contact an economist who believes there is a 30% probability the economy will remain strong. So that's 0.3. So P is equal to 0.3. Therefore, Q is going to be equal to 0.7. So that means 0.7 is failure. And a 10% economy, wait a minute. Okay, 10%. They're not wanting the, they want to use 10%. Okay. Okay. So you're going to have to set this up basically as a expected value. Okay, and if I'll just show you, they're going to set it up just like the problem we just did. Watch this. There it is. Okay. 45,000 remains strong. 45,000 remains strong. 40,000 remains strong. 15,000 economy grows at a moderate pace. I think ours was 20,000. And let me look. I want to make sure. Yeah. Moderate of investment will result in 20,000. And that would be and 45,000, and this would be 40,000 if 10%. So that's where they're getting, see, you got to add these up to get. So that would be 0.75. Ours is 0.3. And then 10%, that is a loss. So that means moderate, which is blue. We're going to do blue for moderate. Let me pull my moderate. Is blue, and we're going to do, since 0.3 and that's 0.4, Moderate is going to be 0.6. Okay, because 0.6 and 0.3 and 0.1 is equal to 1. And that's what they're doing right here. Okay, now the event, in our event, 40,000 if it, strong, so that'd be 40,000 here with this probability. And then another, let's see, I got that one wrong. Let's see, moderate, 20,000. And we stand to lose if it goes into recession at 40,000. So it looks like to me we're going to have 40,000 times 0.3 plus the moderate would be 20,000. Let me show you what I'm doing here. Plus 20,000 at 0.6 plus, that'd be a loss, that'd be negative 40,000 at 0.1. Now that's the way I see it. Take your handy dandy calculator. And that's going to be, let me type it in, clear and clear. 40,000. Let me do it in parentheses, so I don't got to do separately. 40,000. That's 400,000. Those zeros start to run together. Times 0.3, close parentheses, plus parentheses, 20,000 times 0.6, close parentheses, plus negative 40,000 times 0.1 or 0.10. And I get 20,000 and it's positive. So I get positive 20,000. I don't know if that's what they're asking for, but that means the expected value is positive, so the outcome looks good. So let's see what they want. The expected value is 20,000. Yep. That's a good test question because all you got to do is just line it up. 6.1, 31, 10. 6.1, 31, 10. Let's see what this one says. Okay, I'm going to go over this tomorrow in class, so I'm going to skip this one. And I'll do a video on this one because this one takes a little while to do. You got to use a little bit of algebra on this one. It's not one of my favorite problems, so I'm going to wait on that one. In fact, I'm going to delete all of these, and I'm going to leave 31 still there. And I'm going to move on to 6.2. So I'm going to do 6.131 in class. All right, so here we go. 6.2, 29/10. Okay. Okay, this is a calculator problem. This problem, they give you a an n is equal to 6 and p is equal to 0.6, and they want you to fill in where x is equal to 0, 1, 2, 3, 4, 5, 6. So you got to type in each one of those into precise PDF. So binomial PDF parentheses 6.6 and each one of these x's. So that's what you're doing on this problem. So I'm going to take my calculator and I'm going to clear, and then I'm going to clear, and then I'm going to go to second vars binomial PDF, and I'm going to type in 6.6 and 0. And that gives me 0.0041. 0.0041. And as a custom, I always keep mine to 4 digits. Now watch this. I'm going to hit second, enter, and it pulls back the last thing I typed in. I'm going to change that to 1. 0.0369. 0.0369. Second entry, change that to a 2. 0.1382. Second entry, change that to a 3. 0.2765. Second entry, change that to a 4. 0.3110. 5. Second entry, change that to a 5. 0.1866. And the last one, change that to a 6. And you have just completed your probability distribution 467. 0467. And this is just like you have in 6.1. They may ask you to find the mean equals summation of x times p of x. They may ask you to find the standard deviation, which is x squared times p of x minus mu squared. And of course, you can do this in your calculator. Or they may ask you for do it by hand, NP, and standard deviation is equal to the square root of NPQ. Well, you need Q. So go ahead and put Q up here. Q is equal to 0.4 because that's the complement to 0.6. So now you can do this on the calculator and you can do this by hand. This on the calculator and this by hand. So I'm going to do it by hand because I think most of you can do this on the calculator now. And it should match up with what I do by hand. So that's going to be equal to 6 times 0.6. Well, 10% of 6 is 0.6. So 60%, that would be 0.6 times 6, which is 3.6. Okay, and the square root, this is going to be the square root of 3.6 times 0.4, and the 10% of 3.6 is 0.36, times 4 is 144, 1.44, and that's going to be 1.2. Y'all check my math there, but I think that's going to be 1.2 when you finish. Now, again, you have the mean and the standard deviation. You could be asked in some questions to draw the curve with 3 standard deviations on the right, 3 standard deviations on the left, 3.6, 4.8, 6.0, 7.2. This is 3.6 minus 1.2. Oh me, what is that? 2.4, 2.4, 1.2, and 0. So they could ask you to do this. Long as they give you the mean, if they ask for the mean and the standard deviation, then they can ask you to draw the curve, because that's something you should have learned back in chapter 3.
Gmail.
And there is the normal. So pink is unusual. So if they say, would it be unusual for 0 things to happen? Yes, that would be unusual. Is it unusual for 7 things to happen? Yes, that would be unusual. Okay, so anytime they ask for the mean and the standard deviation, they can make you draw the curve and ask you a question about the curve. Okay? And I'm not going to type all those. Well, I guess I better so you can see. All right, 0.0041 tab, 0.0369 tab, 0.1382 tab, 0.2765 tab, 0.3110 tab, 0.1866 tab, and 0.0467. And check it. And there you go. The mean, well, it just so happens that no matter how you do the mean, you're going to come out with the same answers. So that's going to be 3.6 and 1.2. And then they're going to ask you to do it by hand like I did. And that's 3.6 and 1.2. And most of the time, they're going to be the same, unless you got a lot of decimals, and then it could be a little bit off. Okay? Now, let's see what this one looks like. Well, it starts off slow with 0. Gradually, the middle is where everything is. Then it kind of sloughs off. So it would be slightly skewed right, or it could be a normal. It might be C. Yep. Because most of the data is in the middle. And that's symmetric. Well, it's slightly skewed right. Okay, then I don't know what it is. Bimodal, I don't know. It's skewed left. Oh, yeah, because most of the data is on the right. I'm sorry. I had it backwards. Good problem. Good problem. A little bit too time consuming for a test question, but there's good test questions in it. 6.23111. 6.23111. 6.23111. Okay, same type question. You're going to fill in. I'm going to draw a big X and P of X. You're going to make a binomial distribution using NP and X. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not going to do all of them. I'm just going to do the first one, the middle one, and the last one. So I'm going to do clear and clear. And you're going to use second bars, PDF. Oh, shoot. Hold on a minute. And I'm going to type in 9.25 and 0. And that is 0.0751. And I'm going to do second, enter, and I'm going to put in a 5. 0.0389. And I'm going to put in a 9. Second, enter, and I'm going to put in a 9. That's 5 zeros, so you can say 0, 0, 0, 0. Okay, so my question looks like this. That's what it looks like so far. N is equal to, what was it, 9? N is equal to 9. P is equal to 0.25. Therefore, Q is equal to 0.75. And I can go ahead and do the mean and the standard deviation. Mean by hand is 9 times 0.25. Okay, so 0.18 or 1.8 would be 20%. I'm thinking. I would say 1.8 and then 4.5. I'm thinking out loud. It's going to be 1 point. I can't do it in my head right now. So let me just do it. 0.9 times 0.25. I was thinking it would be 1.845, but I don't think that's right. 2.25. So mu is equal to 2.25, and the standard deviation is equal to the square root of 2.25 times 0.75. And I'm going to raise that to the 0.5 power, 6875. I'm going to raise that to the 0.5 power. I get 1.299. So if you're doing it by hand, you don't even have to touch the calculator. There's everything you need. And remember, all this is given. N is equal to 9, P is equal to 0.25, and U calculate the complement. And this is probably what they're going to ask for, and that's what they're going to ask for. They may ask you to draw a curve. They may ask you to do this in your calculator. Put all these numbers in your calculator and do it that way, but it's the same thing. I'm not typing all those in, but I will type in numbers and finish it out so you can see what the answer is. Check, check, check. And let's see, number 0. I got 0751, 0751. For 5, I got 0.0389. And for 9, 0.0000. Mu is equal to 2.25. And standard deviation is equal to 1.30. And the same thing, it's the same thing, 2.25 and 1.30. And what does it look like? Well, it's a little bit skewed right. Let's see, skewed right. If you was to graph it, I'd say delta. Skewed right. And that's it. And that's 6.231/11. All right. 6.23512. 6.23512. Let's see what this one looks like. According to an airline, flights on a certain route are on time 75% of the time. P is equal to 0.75. Therefore, Q is equal to 0.25. N is equal to 24. Okay. Now remember what I told you. The trials are independent. There is 2 outcomes. There's a fixed number of trials. And the probability of success is the same for each experiment. I'm going to leave that up for about 10 seconds so you can write those down. Hit pause and write those down. That should be the answer. The probability exactly, that's PDF. Okay, so I'm going to go to my handy dandy. So A is the trials are independent, 2 mutual exclusive. What else? Fixed number of trials. And success is the same. Success and failure is equal. All right, B. N, PDF. N is 24. P is 0.75. And X is 14. Okay, so set exact. When you see the word exact with these, that means PDF, precise. And it means on a number line from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, all the way up to 24. I'm sorry. 24. Okay, or 25. 24. All right, they want exact. Exact means a little dot on 14. A little dot on 14. No shading. Just what is the probability of 14? And you type that into your PDF. Let's see, second, enter, second, And oh, forget it. I hit the wrong button. Let me just clear everything. I'm about ready to scream. Clear. There. Okay, so I'm going to type in second vars binomial PDF meaning precise, and that's going to be 24 24.25, no, 0.75. I'm tired. 0.75 and 14. And that probability is 0.0333. Okay, next question. 0.0333. Next question. Well, if 100 trials with 0.333, 1, 2, that would be 3 flights. Move the decimal 2 places to the right. What is the probability that fewer than 14 flights? So B or C. Fewer than 14. Well, fewer than 14, that would be 13 and below. Fewer than 14 would be 13, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that means cumulative up to 13. Okay, it doesn't say equal to, it says fewer than. So we're going to use cumulative. We're going to use our cumulative function, and that's going to be second vars cumulative, which is B, and it starts at 0 and it ends at 13. So 24.75 and 13. Now the reason I'm not including 14 is because it says less than 14. And that is 0.0213. 0.0213. And we'll type that in. 0.0213. And move the decimal 2 places to the right. That will be 2 flights. And then D, at least 14 flights. Okay, so D is at least 14 flights. Well, if you're doing at least 14 flights, I'm trying to get at least 14 flights. Well, at least 14 is going to be, the lowest number is 14. That's going to be 14, 15, 16, 17, all the way up to 24. So I'm going to take my probability of 1, and I'm going to subtract the probability of all these guys, and that's going to leave this probability right here. So I'm going to subtract 0.0213, and that's going to give me let's see, 0.9787. 0.9787, and that is that probability, if I did my math right in my head, 0.9787. 0.9787. And E, well, move the decimal, that'd be 98 flights. Move the decimal 2 places to the right. And since they got inclusive, and we did this in my night class, that inclusive means that you're going to include 12 and 14. So I'm going to take my handy dandy whiteboard and I'm going to do 12 and 14. I'm going to do it in orange. 12, 13, 14. So you're going to add those 3 probabilities up. Okay? And I'm not going to do that on the paper. And write it on the paper. Let me do D or E. I'm going to do NP 12 plus NP 13 plus NP 14 in my calculator. Okay, so let's do it. Take a calculator, and I'm going to do second, enter, second, enter. There we go, and I'm going to change this to a, well, there's 14 right there. 14 is 0.003 or whatever, 0.0333. 0.0333, and then I'm going to change the second entry and change that to a 13, and that's 0.0141, 0.0141, and then change that to a 12. And that is 0.0051. And I'm going to add 0.0141, 0.0141, and I'm going to add 0.0333. And that is 0.0525. 0.0525. And if you move the decimal 2 places to the right, that's going to be 5 flights. And that is a good, not the whole test question, but each one of these, A through or B through E, are good test questions. Next test question, or next homework question, is 2.4 or 6.2 41 13. 6.2 41 13. 6.2 41/13. I think I've already done this one. Okay. 14 jurors. So N is equal to 14. P is equal to 0.42. Therefore, Q is equal to 0.58. And 2 jurors are in the minority. 2 jurors are minority. And A asks, what is the probability that the 2 jurors minority will be on the whatever? And that's going to be equal to 2/14, which is 1/7, whatever that comes out to be. Okay, so I'm just giving you a little bit of a, okay, there's the first question, A. Okay, I'm not going to do the decimal because you can do that in your calculator. B, if 14 jurors are randomly selected where 42 are minorities, what is the probability that 2 or fewer juries will be minorities? So draw your number line. B, 2 or fewer. Draw your number line, 14, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And they want to know 2, 1, and 0. So CDF to 2, 14.42 and 2. I'm not going to do that, but that's it. Okay. And what will you say as far as the minorities? Well, there's not enough. You got 4 million people, and you come together for a jury, and there's only 2 people, and the probability of 2 or less is, let's do that, CDF. Let's do CDF right quick, just to do it. Oh, I'm about tired. CDF, second vars, CDF, binomial. And that's going to be 14.42. And is this is CDF, so that would be 2. 0.0287. 0.0287. And what is 1 divided by 7? 0.14. So you've got a 14% chance that the 2 minorities you have are going to sit on the jury. You got a 14% chance that the 2 minorities that are on jury duty right now, you got a 14% chance that they are going to be on that jury. And then you've got a 2 or 3% chance that 2 or fewer minorities were going to be on the jury. If I was a lawyer representing somebody of the minority, I would say, no way. We've got what, 4 million people in this town? You can get me more than 2 minorities on jury duty. That's what I would say if I was a lawyer representing a minority and 4 million people have been asked and they can only get 2. No. Okay, that's 6.24113. Next question. 6.24614. 6.246/14. According to a report, 71.5% of murders are committed by people with firearms. Okay, we're immediately, before we even start, I'm going to write probability of firearms is 0.715. Therefore, Q is equal to 0.285. And they give us, in the second part of the question, they say, if 100 murders are randomly selected, how many would we expect to be committed by people with firearms? Okay, so 100 people. So that would be A, 100 times 0.715. 72 people would be 72 people with firearms would be expected. Okay, now this is where they're going to ask for you to draw the curve because they want you to find the mean and the standard deviation. So this is NP, N times P. So we just need, we know that the mean, B, we know that the mean is equal to 72. And the standard deviation is equal to the square root of 72 times 0.285. Now you're going to have to do this on a calculator because I can't do 0.285 in my head. So 72, clear, 72 times 0.285. And I get the square root of 20.52. Square root of 20.52. So I'm going to raise that to the 0.5 power. And I get 4.53. And I'm going to say that's equal to 5 because I'm not going to work with decimals on my curve because I don't feel like doing it right now. All right, so I've got my mean. I've got my mean and my standard deviation. So now I'm going to draw the curve. And I don't have to draw it because I've got my sheets that we made up in chapter 3. And my mean is equal to 70 what? 72. And I got a standard deviation of 5. So that's going to be 77. And 5 is 82. And 5 is 87. 5 from, that'd be 67, 62, and 57. So our two standard deviations to the right and two standard deviations to the left is normal. Oops. So we all know that's normal and represents 95%. And the red, or the yellow and the red, is the unusual. And what number do they want us to ask about? Let's go back to the question. They're asking about B. Would it be unusual to observe 83 murders by people with firearms? Would that be unusual? 83. 83. Where is 83? So let's plot 83. Oops. 83 is in the pink. So 83 is unusual. Because it is outside of the green, which is two standard deviations. And 83 is greater than two standard deviations, or you can say yes, because 83 is outside the green area. Yay! Now, I cannot remember how many problems I did, but I'm going to delete these, except for the one that we're going to go over in class tomorrow. And I'm going to count the number of problems I did. I think these are it. So you can check. That's one we just did. Let's see. 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe we got 10 in today. That's 10 questions, 10 homework questions. All right, I hope this helps. I had a couple of people asking me to go over these questions. So hopefully that'll help, and I'll post it on all 3 Math 120s. Thank y'all.